A rancher plans to fence in a rectangle corral adjacent to a river for a herd of cattle. The corral must contain 135,200 square meters in order to provide enough grass for the herd. No fences are required along the river. Use calculus to determine the dimensions of the corral that will require the least amount of fencing. How much fencing is required? Okay, so the problem is we are given that the area must be 135,200 square meters. And then the area equation for us, it looks like it's going to be x times y, length times width. And they also said what is the corral needed. So we'll call that, in a sense, perimeter P is equal to 2x's plus a y. Okay. So we want to find the least amount of fencing. So we're going to optimize our P equation here. And the way we do that is take the derivative. But as we've talked about before, we don't want to take the derivative of these two different variables. So we'll just pick one. I think maybe we'll pick the solve for y, right? And then we'll keep our x's. So this is the second equation that we're going to use as a, in sense, a sacrifice equation. So that's solve for y, right? Y right here. So y is equal to 135,200 divided by x, right? Because we just divided x to the other side. And now we have a substitution for y. So p is equal to 2x plus 135,200. And let's write it over x. And then when we take the derivative of this, so we can optimize it. Because remember, we always take the derivative of the equation that we're trying to optimize, in this case the fence. So not the area, the fence. So it's going to be p prime is equal to the derivative of 2x is just 2. And the derivative of 135,200 over x, remember, is 135,200 x to the negative 1 power. That's how we rewrite it. So it's going to be negative 1, 1, not negative 1, that's right, just write a negative fraction of 135,200 and then over x squared on the bottom, right? Because when we minus 1 from it, that becomes a negative 2. Okay, and when we optimize, we want to make it equal to 0. Let's start moving stuff around. 2 is equal to, let's move the negative fraction over. 135,200 over x squared. Let's move the x squared on top. So it's 2x squared equals to 135,200. We'll divide by 2, and then we'll take the square root of that. X squared equals to 135,200. Let's just leave it as that for now. 135,200 over 2, and we're going to take the square root of both sides. Remember, when you take the square root, it's always plus minus. But since our xy cannot be negative, since this is kind of a real-world fence problem, our x is equal to the square root of 135,200 over 2. Okay, so that is the value of x. So to determine the dimensions, so we have x, we have to find y. We have the equation for y right here. So it's going to be y is equal to 135,200 over x, and x is going to be the square root of 135,200 over 2, and that'll be our y value. And the last question is how much fence is required. So we can actually use this perimeter equation here. P is equal to 2x, which is the square root of 135,200 over 2, plus 135,200 over the square root of 135,200 over 2. Okay. You can plug those numbers into a calculator and you can get some decimal values.